All right, this is lesson 6.1. This is lesson 6.1, and we're going to call this lesson In-Sided Polygons. In-sided polygons. The in stands for the number of sides. So this is saying no matter how many sides of a polygon, which is a shape, okay, no matter how many sides of a polygon I give you, you can figure out how much each angle is inside. You can tell me how many sides there are. You can tell me what all the angles add up to be in the middle of the figure. Okay, so we're going to learn a few of those things. On your brown vocab sheet, there are some of these words, so you might want to get this out. Your brown vocab sheet that says Unit 6. By the way, this needs to be filled out. If you haven't finished your Unit 5 one, you need to get that done at some point. Okay? So, Unit 6, the first word I think is polygons. Okay? You can just put shapes. Yep. Or you can just, underneath facts maybe, I would just put shapes. Polygons are another word called shapes. Okay? We're going to talk about different types of polygons. Okay? The number of sides is represented by the letter N. Okay? So when it says number of sides here, we're going to use the letter N to represent number of sides. So in a triangle, how many sides are there in a triangle? 3. Did you almost say 4?
No, I didn't.
Yeah, you did.
I was going to confuse paying attention.
All right. Yeah, okay. Okay, and the number of triangles inside a triangle. Well, that seems kind of weird, right? So there's actually only one triangle in this picture, okay? We're going to talk about a couple of the other ones as we look down here. The number of triangles in a triangle, or in a shape, this is going to be really important for us to know, is going to be n minus 2.
Some of us don't have the packet.
Oh, that's because you were absent the day I passed it out. In this triangle, there's only one triangle. That maybe sounds silly. Okay? The sum of the interior angles, how much do all inside of a triangle make? 180. Okay, the way we're going to figure that out is we're going to do the number of triangles, so n minus 2, times 180. That's going to tell us the degrees of the inside angles. Okay, so make sure you put that there, sum of the interior angles. That's one of your vocab actually on that sheet, sum of interior angles. I would put that underneath the facts. It says interior angle sum. See where it says that on your chart, on your interior angle sum. I would put this formula right here. N minus 2 times 180. And then when you need to write about it, it says it should be the number of triangles. Yes.
Wait, what?
Okay. Okay, so we have n minus 2 times 180 as the number of triangles inside. All right, the next thing is a quadrilateral. How many sides does a quadrilateral have? 4. So that means your n value is 4 here. How many triangles are inside a quadrilateral? Look at your example here, right? 1, 2, and we found that by doing our formula. Remember our formula said n minus 2? Well, what was our n value? What's our n value? 4. So then we did 4 minus 2 means that I have 2 triangles inside this one. And then how do we figure out how much all these angles inside the quadrilateral add up to be? We're going to do n minus 2. What was n minus 2? 2, right? Or you can do your, sometimes it's good to show your work. Always it's good to show your work. N minus 2 times 180. Well, we knew that was 4 minus 2 times 180. And 4 minus 2 is, and what is 2 times 180? 360. So that means all of the angles inside a quadrilateral add up to be 360 degrees. Okay? The next thing we have a pentagon. How many sides is a pentagon? 5 sides, right? So that means our in value is 5. How many triangles? If this picture wasn't here, how would you figure that out? How many triangles? You would do 5 minus 2, which is what? Okay, why is only one person talking today? It's Thursday, I know it's rainy, but I need information from you, okay? We have n minus 2, that's our formula. So that means I have 5 minus 2, which gives me 3 triangles inside this thing. And then if I wanted to figure out how much they all add up to be inside of here, what would I do? 3 times 180, right? You all have calculators? Figure that out. 3 times 180. 540. That means inside any pentagon, all the angles add up to be 540 degrees. Inside any pentagon. Okay? The next shape is called a hexagon. I want you to see if you can fill these 3 things out for a hexagon.
Isn't that 8 sides?
Count them.
So you said all the angles in there, like all the
Yep.
the whole inside,
Yeah, so like
like in a
this
triangle.
angle, this angle, this angle, this angle, this angle, and this angle. All of them add up to be whatever you get over there. Okay? So we have 6 sides in hexagon. How many triangles does that mean that I have, Dalton? 4 triangles. Donald, how do I figure out how much all the angles add up to be?
4 times 8.
Perfect. 4 times 180. And what is 4 times 180, Donald?
720.
720. That means if I were to add up all of these angles inside of a hexagon, I should get 720. Now on your vocab sheet, underneath polygon, you have some descriptions of some names, right? All you need to do there is tell me how many sides those are. You don't need to do that right now, but you need to go back in later and say this is a 5 sides, this is 6 sides. So you need to know that vocabulary, okay? All right, a heptagon is 7 sides. Do you see the trend here? We're going 3, 4, 5, 6, 7. So they didn't draw a heptagon for you, but a heptagon is 7 sides.
What did it look like?
A hexagon with one more side. You're not going to be asked to draw one. Okay.
No.
So 7 sides. How many triangles are in it then, Austin? 5 triangles. Brooklyn, how are we going to figure out how much they add up to be inside of a heptagon? Okay, we're going to multiply the number of triangles, which is 5 times 180. Make sure you're thinking it's the number of triangles times 180, not the number of sides times 180. And Brooklyn, what is 5 times 180? Well, I'm sorry, what did you say? 900. Okay. Okay, I'd like you to take a few minutes and finish the rest of these. Finish these next 3 rows. It goes 7, 8, 9, I'll tell you that. Octagon is 8 sides. Nonagon is 9 sides. Decagon is 10 sides. Okay? Pause the video and finish the chart, please. Okay, check your answers with the chart. All right, the next thing it says is the sum of the interior angles formula. That's what we've been doing, the sum of the interior angles. We know we can get the sum of the interior angles by doing n minus 2 times 180. And we've already filled that in on our chart. N minus 2 times 180. Now, let's look at number 10, the decagon. If I have a decagon drawn, and I know that all the angles inside the decagon add up to be 1440, how could I figure out how much each angle is inside the decagon? Divide by the number of sides, right? So if I took this number and I divided this by 10, I would get 144. That means each angle is going to be 144. So each angle would be 144. So we take the total number of the inside and we divided it by the number of sides. Okay? So on your formula, we're going to create a formula down here. We have space. Okay, it says, therefore, all angles are equal. There's your blank down there. All angles are equal. I'll go ahead and move this up. Okay, so our formula for that is going to be to find out how much each angle is. We're going to do n minus 2 times 180 because that gave us the total, right? N minus 2 times 180 gives me the total. And then what did I say I needed to do with that number? Divide by the number of sides. And what variable gives us the number of sides? What variable have we been using that gives us the number of sides? N. So we're going to divide this by n. So on your chart, this is the formula. Okay? So I would transfer this to your chart where it says each interior angle. And I would write this down. And then I would make myself a note that said something like this. Number of triangles times 180, and then divide by number of sides. That's the interpretation of what you just wrote. N minus 2 times 180, so the number of triangles times 180, divided by the number of sides. That's going to give you each interior angle. Okay, so let's do some actual examples of what this would look like. Number 1 on the back page says, find the sum of the interior angles of a 15-gon. After 12 sides, the number of sides, the polygon is called whatever the number of sides is, and then you slap a gon on the end. So like a 30-sided figure would be a 30-gon. A 100-sided figure would be called a 100-gon. You know, pretty original here. So the one that has a special name is 20, and that's called an icosagon, but you don't need to know that. Okay, so find the sum of the interior angles of a 15-gon. So the first thing we need to know is our n. How many sides are there? There are 15. So we know that our n value is 15. Now it said find the sum, right? It didn't say find out how much each one was, but it said find the sum. And you have your brown chart. If we want to find the sum, don't we just need to do the number of triangles times 180? Right? So that was this formula. N minus 2 times 180. How many triangles are there in a 15-gon?
13.
There's 13, right? We can just take the number of sides and subtract 2, always. So there are 13 triangles times 180. You all have a calculator? 13 times 180. Sebastian?
I got
2,340. Anybody agree with that? All right. So that means in a 15-gon, all the angles add up to be 2,340. Why don't you try number 2 on your own and then check with your neighbor? Go ahead and pause the video. Awesome. So in a 21-gon, there are 3,420 degrees. Okay, number 3. What is the measure of each interior angle of a regular pentagon? Who remembers how many sides a pentagon has? Ooh, be careful. 5. 5. You're just seeing if I was paying attention. Okay, so we have to find how much total inside, right? So total inside means I have to take the number of triangles. How many triangles are there in a pentagon? 3. So I do the 3 times 180. What is that? 540? Okay, now that's the total of all 5 angles, right? So if I want to figure out how much each angle is, Abby, what do I need to do with this 540? Divide it by 5. Good, because that means I'm going to divide the 540 up into 5 different angles. Leanna, what are you getting? 108 degrees. So each angle inside of a pentagon is 108 degrees. Okay?
Do we have to put the little degree bubble?
You don't have to, but it's good practice. I forgot to on the previous 2. All right, try number 4. See if you can do number 4 on your own. Go ahead and pause the video and try number 4. So we get 160 degrees for each angle. Okay, any questions about this so far? Okay, the next thing we have is exterior angles. It says exterior angles are always supplementary to their adjacent interior angle. Whoa. On the polygons below, find the measure of each exterior angle along with the sum of the exterior angles. Okay, it's a lot of words. This is what it means. Every interior angle has an exterior angle. So if you look at this first example, would you agree that 79 and this angle right here, this one's inside, this one's exterior, right? And together they make how much? We know this. Oh, music to my ears. You have learned something. Okay, I am done for the day. No, I'm just kidding. You wish. So if we want to figure out how much that exterior angle is, what are we going to do? Subtract. Okay, everyone do that. What is 180 minus 79? 101. Okay? So that means that this angle is 101. What about down here? If this one's 40, can we figure out how much that exterior angle is down here? Okay, so 180 minus 40. 140.
No way.
What about over here? What can we do over here? We know that these two together have to make 180. Okay. So 180 minus 61, Austin? I'm sorry? 119. So that's how we can figure out how much the exterior angles are. Let's see what the sum of them is. So if we add the exterior angles together, see what you come up with. Add all your exterior angles up. Sebastian, give us the answer in 5, 4, 3, 2, 1. 360. Did anybody else get 360? Woo! Check that math. Check that math again, Crystal. Okay, so let's try this down here. Let's jump down to the hexagon. Okay? Now, even though I have 6 angles, I still know that an interior and an exterior together make how much? 180, right? So even though there are 6 of them, each group makes 180. So I'd like you to take a minute, find out how much each exterior angle is. We're on the hexagon. And then add up all the exterior angles. Do not say your answer out loud. Take a minute, pause the video, and complete that task. Okay, so Leanna did a different problem, and she still got 360. Do you think it's coincidence that we've gotten 360 twice and Leanna 3 times? So what can we then conjecture, bless you, about all the exterior angles? Always will do what? They'll always add up to be 360. So on your brown paper, where it says exterior angle sum, I would write always add up to be 360.
Where are you seeing these words?
Well, you go to unit 6 first. Okay, you're on the wrong, oh my gosh. If you flip the page back, my love. Wait. Oh. Right? Always. Don't forget it.
You're not always right, Miss Miriam. What is always?
Always adds up to be 360 degrees. So that's the little conclusion there at the bottom. Okay, let's practice. Let's practice this a little bit. We already know what is the measure of each exterior angle of a hexagon. So let's talk about this. A hexagon is how many? 6. So what is all the exterior angles add up to be? 360. Okay? But if I want to figure out how much each exterior angle is, when you see this word regular, guys, this word regular means that all the angles are the same. The example we just did of that hexagon, the angles weren't all the same, so that's not a regular hexagon. A regular means that all the angles are the same. So in number 5, it says, if we know that all of them are 360, how can I figure out how much each one is? What do I need to do? Divide by 6. That's the number of sides. So 360 divided by 6, 60. So each exterior angle in a hexagon is 60 degrees. Okay, what about number 6? It says, what's the measure of each exterior angle of a 24gon? Well, first, how much do all the exterior angles add up to be? 360, no matter the size, right? And what are we going to divide by this time? 24. 360 divided by 24? So each exterior angle is 15 degrees. So I think you have one more column on your chart that says each exterior angle. We get each exterior angle by taking 360 and dividing by what? The number of sides. N. Thank you, Cedric. We're taking 360 and dividing by n. So where it says each exterior angle, this is how you figure it out. 360 divided by n. All right, let's look at number 7. It says, if the exterior angle of a regular polygon measures 12 degrees, how many sides does it have? So now they're giving you the answer, and they want you to figure out n, right? So it's a good thing that we have a formula. We know that 360 divided by n. This time they're telling me it has to be how many? What does it equal? 12. So here's our equation. Okay, we don't know what n is, but they're telling us that we know it equals 12. What are we going to do to get n by itself or solve for n? What do we have to do here? Multiply by n on each side. Okay, so then we have 360 equals 12n. How do we solve this? Divide by 12. What are you getting for n? 30. So that means there are 30 sides. So what do we call this shape? A 30gon. So you need to write that. This is a 30gon. Yeah, remember after 12 it's just the number gone. Except for 20, which is an icosagon. Icosagon? Icosagon. That's 20 sides. Okay. Try number 8 on your own, please. Try number 8 on your own. Go ahead and pause the video and try number 8. We should have done 360 divided by n equals 40. So when we multiply by n on each side, I get 360 equals 40n. When I divide by 40, Aaliyah, what's 360 divided by 40? 9? Okay. What's a 9-sided figure called, Benny? A what? A nonagon.
It's not enough.
Except it's non, not not.
You want to get you want to crush my brain.
A nonagon. Okay? Questions on that? All right, we're going to do a couple quick examples and then we're going to be done. Okay? Okay, let's fill this in really quickly. These are your formulas that you have on your sheet, but let's fill this in really quickly. The sum of the interior angles. If I want to find out all the interior angles on the inside, remember we do n minus 2 times 180. The number of triangles times 180. If I want to figure out how much each interior angle is, I do n minus 2 times 180. And then I am dividing by n. What about the sum of the exterior angles? All the exterior angles always make 360 no matter what. So that one, can't really do anything with that. The exterior angle, what do we do with that? 360 divided by n. And then the number of sides is represented by what variable? N. Okay, so this is a good quick reference for you. It's also on your sheet. Okay, so let's try. Okay, let's try number 5. Number 5 says 5 angles of a hexagon measure these things. What is the measure of the 6th angle? Okay, so the first thing we need to know is what? What's the first thing we need to know? It doesn't say anything about exterior angles. Okay, think about this, guys. If I told you that I have a triangle, and I know that this one's 50 and this is 60, how do we figure out this one right here? We subtracted it from 180, and what is 180? Is it 180 the total? Right, so we have to know the total first. So on number 5, I need to know the total of a hexagon first, right? How are we going to figure out the total of a hexagon without looking back at our chart that's already filled in? Okay, 6 sides minus 2 times 180. All right, so we have to figure out the total first. So 4 times 180 is? 6 minus 2 is 4. 720. So I know that all 6 angles in a hexagon are going to add up to be 720. And I have 5 of the 6 angles, don't I? What could we say that 6th angle is called? What could we say? Say that again, Ashley. X. All right. So we are all about setting up equations. X, which is the 6th angle, plus 119, plus 129, plus 104, plus 139, plus 95. All of those have to equal how much? 720. This is showing your work. And you better write this example down because you're going to have some like this. Okay? Now we get to use our calculator. Okay?
I got 134.
You got 134 after you added 5 angles together?
Well, 5 angles.
586 is what I was looking for.
Yeah, that's what I got.
Okay, x plus 586 equals 720. Okay, now Crystal, you said you got what?
134.
Did anyone else get 134 for the missing angle? Okay,
Sorry,
That's
I'm
that.
giving the answer, not the-
6th side. Okay, questions on number 5? Okay, let's jump down to number 7. We're on number 7. The sum of the interior angles of a polygon is 3960. So they are giving you the sum of the interior angles. So the best thing to do is to look up at the formula. The sum of the interior angles we know is n minus 2 times 180. They're telling you that it equals 3,960. Okay, so we don't know what our n is, but we do know that we have 3,960. How might we solve this problem for n? What could you do first? We need to find out what n is. Sebastian?
Couldn't you multiply the 180 to
Okay, so Sebastian is saying distribute, right? Okay, so let's go ahead and distribute. So I'm getting 180n minus 360 equals 3,960. Is this something that you guys can solve now? Okay, go ahead and do that.
I was trying to suggest dividing by 360, but
You mean divide by 180?
we'll divide by, well,
Don't divide by 360. That's going to give you the incorrect answer. If you wanted to get the 180 off of here, you could divide each side by 180 and that would make it go away. But not 360.
So there are two ways to do this? Or
The easiest way that makes the most sense to students is to distribute the 180 and then solve it. Donald, do you have an answer for N?
20.
20. Anybody else get 20? You got what?
I got 24.
Okay. All right. So when we add 360, what do we get? Did you subtract 360?
Yeah.
Okay, so we get 24. So what is this shape called? A 24gon.
I don't like these terms.
Okay. Let's keep going. Okay, let's look at number 11. It says, if the interior angle of a regular polygon measures 108, how many sides does it have? So the formula we're looking for here, it says interior angle. So we know how to find each interior angle, right? We do n minus 2 times 180, but then what else do we have to do? Divided by n. Okay, so that's our formula to figure it out, each interior angle. But it tells us that it equals 108. Okay, so we set up our formula and equal it to 108. How are we going to solve this problem? We've done one similar to this. What do we need to get rid of first? The n, get rid of that fraction. How do we get rid of n? Multiply it by each side. And on my next step, guys, I'm going to go ahead and distribute here. Okay? So I'm going to go ahead and make this 180n minus 360 equals 108n. Okay, yeah, and now it's just an Algebra 1 problem, right? Get your n's on the same side. I would move 180 over. I would subtract 180 because you already have an n over there. So if we subtract 180n, I have negative 360 equals negative 72n. Can you have a negative number of sides? No, but this is, go ahead, Leanna.
But when you when you divide, you're going to have a positive.
Okay, because when we divide off, we're actually going to get a positive number, right? So negative 360 divided by negative 72? 5. So what kind of a figure is this? What's this called? Pentagon. Who said a 5-gon? It's a pentagon. Are we kind of getting the hang of this?
No.
Perfect. Okay, let's look at number 13, I think. Let me look here real quick. Yeah, let's look at 16. What?
It doesn't. I need to go home.
Okay.
Yes.
Number 16. It says solve for x. Okay, what do all those little hash marks mean on number 16? All the sides are the same, right? If all the sides are the same, what do you know about all the angles? They're all the same. Count how many sides there are in this picture. Don't shout it out, but just count how many sides there are on this picture, please.
37.
Number 13 is a heptagon.
Awesome. So there you know what it looks like. Okay, how many sides are we getting here?
37.
No, 10.
Where you getting 37?
She's just being silly. Okay, so there are 10 sides. We need to figure out how much the total is inside, right? Before I can set anything up, I need to figure out how much is the total inside. How do we figure out the total inside? I want you to do that on your paper. Look back. How do you figure out how much the sum is? That's the total inside. Go ahead and pause the video. Okay, so the total inside is going to be 10 minus 8. Whoa, just kidding. 10 minus 2 times 180. So what is 8 times 180, folks? 1440. So we know inside total, I should get 1440, right? How many angles did we say we had? 10 angles. And each angle is 10x plus 4. So we could do 10x plus 4 plus 10x plus 4 to split it up all the way 10 times, or what could I do instead? Not divide by 10. I can multiply by 10, right? I know I have 10 sides, or 10 angles. And if each of them are 10x plus 4, and it has to equal how much?
1440.
1440. Okay, take a minute and solve this one out. Press pause. Okay, so we should be getting x to be 14. All right, so we have some examples here, and you have homework for when you get done with your test.
Oh my god.
If you flip over to page 5, okay, I'd like you to do, listen carefully on page 5, this is homework 27. I'd like you to do 1 through 8 all. 1 through 8 all. And then I'd like you to do 10 through 18 even. 10 through 18 even. Okay? So 1 through 8 all, and then 10 through 18 even.